Hello, my name is Nohai, and this is Physics 2211 Lab 3 Black Hole. So the purpose of this lab is to analyze the star's motion to find the mass of the black hole, and then find the initial speed of the spacecraft that does not collide with the black hole or the planet. So for the fundamental principles, here we have Newton's second law, which is F net equals change in momentum over change in time, and we can derive the above from the change in momentum formula. So the change in the rate of momentum can be divided into two components, which are parallel and perpendicular forces. And the following are like the formulas to find each component. And lastly, we have universal gravitational force, which is just F grav equals negative gravitational constant times m1 times m2 divided by magnitude of r squared times the r hat. And here g is the universal gravitational constant, which is 6.67 times 10 to the negative 11. m1 and m2 are the masses of the objects, and r is the displacement of the two objects. So to briefly talk about the result of this lab, mass of the black hole was approximately 1.28405 times 10 to the negative 34 kilograms, and initial velocity of the spaceship was x component was negative 10.6 times 10 to the 6, and y component was 10 times 10 to the 6, and z component was 0, and unit was meters per second. So part 1 was to find the mass of the black hole. The system was the star, surrounding was the black hole. The initial conditions that I edited were mass of the star, which was 2.0 times 10 to the 30, and delta t was 86,400 seconds. Following that, I found initial momentum, final momentum, F net p hat, dp over dt parallel, dp over dt perpendicular, to use the universal gravitational force formula. And then with that formula, I isolated the mass of the black hole to the left side to find the mass of the black hole. As a result, the magnitude of F net was 8.63387 times 10 to the 28. F net parallel was 3.67521 times 10 to the 27, and then the F net perpendicular was 8.62397 times 10 to the 28. And lastly, the averaged mass of the black hole was 1.28405 times 10 to the 34 kilograms. Part 2, our system and the surroundings got changed. So first of all, the system was spaceship, surroundings were black hole and the star. Initial conditions that I edited were mass of the black hole, which is just from part 1, and initial velocity of the ship. I got negative 10.6 times 10 to the 6 as the x, and 10 times 10 to the 6 as the y, and we ignore z. And the unit is meters per second. So after that, as you can see, F net acting on the planet and F net acting on the ship were calculated. And then velocity and position update formulas were used to calculate v final and momentum final. And lastly, the initial velocity of the ship was guessed, and the x direction of the velocity of the ship had to be less than 0 since it moves towards the black hole. And as a result, like I said, the initial velocity of the ship was guessed, and it was negative 10.6 times 10 to the 6, and y was like 10 times 10 to the 6 meters per second. And the ship is now 3.28921 times 10 to the 10 meters away from the event horizon of the black hole. Possible sources of errors, such as the averaged mass of the black hole, might not be accurate enough. There may have been human errors since the initial velocity of the ship was calculated using the guess and check method. So what is the difference between net force and the rate of change in momentum? So mathematically, net force and the rate of change in momentum are basically the same thing. F net, or net force, is all the external forces acting on the object, and F net parallel is just net force parallel to the motion of an object. F net perpendicular is just net force perpendicular to the motion of an object. And rate of change in momentum, which is dp over dt, is change in momentum over a given time interval. It can also be written as final momentum minus the initial momentum over delta t. It could be easier to find the rate of change in momentum in some situations. Part 2, we found out of the initial velocity at which the spaceship does not collide with the planet or the black hole. But now we want to find out what initial velocity of the spaceship is needed to make sure it enters into some kind of orbit around the black hole. And again, I used the guess and check method. The velocity was negative 1.1 times 10 to the 6 for the x component and 9.28 times 10 to the 6 for the y component. So in conclusion, Newton's second law and universal gravitational force were effectively used to calculate the mass of the black hole and the velocity of the ship. Alright, that's it for today. Thank you for listening.